Now my dear student, now I continue from projectile motion, the horizontal range. Third point is the horizontal range. You know time of flight is equal to T, capital T is equal to 2u sin theta by g, and maximum height attained h is equal to u square sin square theta by 2g. Now third one point from our 5 marks question, horizontal range. You have to draw this one, the point of projection O. The point at which the projectile hits the ground, that is OA. It is the horizontal distance. That horizontal distance is known as range, and it is denoted by capital R. You see in this diagram. So I define the maximum horizontal distance between the point of projection and the point at which the projectile hits the ground. It is called horizontal range. It is denoted by capital R. For horizontal motion, x is equal to uxt plus half ax into t square. All of you know that motion along horizontal is always remains constant, so that acceleration along x-axis is equal to 0. ठीक है? Then x is equal to r. This is the total horizontal distance x covered by the projectile. Therefore, x is equal to r. Ux is equal to u cos theta. T is equal to capital T. That is the total time taken from O to A. So that small t is equal to capital T. That is called time of flight. And that time of flight is equal to 2u sin theta by g. Ax is equal to 0. Because motion along horizontal is always remains constant. Therefore, acceleration along x-axis is equal to 0. Therefore, r is equal to, we put this value in this equation, r is equal to u cos theta into t plus 0 is equal to r is equal to u cos theta into capital T. That capital T is the time of flight. Now we know time of flight T is equal to 2u sin theta by g. Therefore, r is equal to u cos theta into 2u sin theta by g. Is it clear? We put the value t is equal to 2u sin theta by g. Therefore, r is equal to u cos theta. In place of t, we write 2u sin theta by g. U square. First of all, we write 2. Rearrange the term 2 sin theta into cos theta. 2 sin theta into cos theta is equal to sin 2 theta from the trigonometric formula. Therefore, we write here u square into sin 2 theta by g. Therefore, final expression r is equal to u square sin 2 theta by g. That is the expression for the horizontal range. This horizontal range depends upon the two factors. One is the initial velocity of throw. Second one, angle of projection. The sin will be maximum. Sin have the two value. One is the 0 when theta is equal to 0. Sin maximum is equal to 1 when sin theta is equal to sin 90, then its value becomes maximum 1. Therefore, the range of projectile will be maximum if sin 2 theta is equal to 1. Therefore, r max is equal to r max. R max is equal to u square by g into 1. Therefore, r max formula is equal to u square by g. Now, sin 2 theta is equal to 1 when sin 90. Sin cancel out. We taking the inverse and cancel out. 2 theta is equal to 90 degree. Therefore, theta is equal to 45 degree. Any object which can thrown at an angle of 45 degree, it covers a maximum horizontal range. Any object, a projectile, when thrown at an angle of 45 degree, then it covers a maximum horizontal range. Is it clear? Suppose we throw a javelin. If we throw a javelin at an angle of 45 degree, then the javelin will covers maximum horizontal distance. Is it? When a short put is thrown at an angle of 45 degree, then it will cover a maximum horizontal, maximum distance on the ground. During playing, all of you try it, then you will get the result. Now, more important question is that for two angle of projection for the same range of projectile. Is it or not? You see that one diagram. Projectile is thrown, two projectile is thrown, one is thrown theta and complementary angle is equal to 90 minus theta. Sum of complementary angle is equal to 90 degree theta plus 90 minus theta. 90 minus theta is equal to theta. For a first angle of projection, theta 1 is equal to theta. Therefore, R1 is equal to u square sine 2 theta by g. Equation number 1. For second angle of projection, theta 2 is equal to 90 minus theta. Therefore, R2 is equal to u square sine 2 90 minus theta by g. Now we solve it. U square sine 180 minus 2 theta by g. Sine 180 minus 2 theta is equal to sine 2 theta. Therefore, R2 is equal to u square sine 2 theta by g. Equation number 2. From equation 1 and 2, you see that right hand side are equal. So, left hand side also equal. Therefore, we write an as equation 1 and 2, R1 is equal to R2. Therefore, the range of projectile will be same for the two angle of projection, that is theta and 90 minus theta with the horizontal. When a projectile is thrown at an angle of 30 degree and 60 degree, sum of two complementary angle is equal to 90 degree. All of you know, the 30 plus 60 is equal to 90. Is it clear? When the projectile is thrown at an angle, theta 1 is equal to 45 plus theta and theta 2 is equal to 45 minus theta. They will also cover the same range. When the projectile is thrown at an angle of 15 degree and 75 degree, they will be cover the same range. When a projectile is thrown at an angle of 45 degree, they cover the maximum range. These are the important parts of this projectile motion. You have to put that one value, then you will get the result. Time of flight, you know, time of flight t is equal to 2u sine theta by g. Is it clear? Height attained, h is equal to u square sine square theta by 2g. Now third one equation is horizontal range. Horizontal range r is equal to u square sine 2 theta by g. Is it clear? You have to learn that one and solve all type of reasoning question also. Suppose when a projectile is thrown at an angle theta and 90 minus theta, then you have to find the time of flight, ratio of time of flight. Suppose you have to find the range ratio. When a projectile is thrown at an angle theta and 90 minus theta, range is equal to 1. When you put that one value, theta is equal to 30 degrees, theta is equal to 60 degrees, you put the value of theta is equal to 45 degrees, whatever you want, you can do it. You have the formula. Is it clear, my dear student? Now, I go. The next one, important point also, the velocity of the projectile at any instant of time. When a projectile is thrown at an angle theta with initial velocity u. Always we throw with initial velocity u. So that resolve u into two components. Along x-axis, ux is equal to u cos theta. Along y-axis, uy is equal to u sin theta. Now, the projectile at any time t reaches at point P. For the horizontal motion, the component of velocity, the velocity of the projectile at point P is equal to v. So, resolve v again into two components, vx and vy. So, for horizontal motion, vy, for horizontal motion, Vx is equal to here by mistake I have written Vx Vx is equal to ux plus ax into t. Along horizontal direction, Vx is equal to ux plus ax into t. Along horizontal, ax is equal to 0 because velocity is uniform. So acceleration along x-axis is equal to 0. Ux is equal to u cos theta. Therefore, Vx is equal to u cos theta. This is equation number 1. Now along vertical motion Vy is equal to Uy plus Ay into t. Therefore Uy is equal to U sin theta, Ay is equal to minus g. Therefore we have the equation Vy is equal to U sin theta minus gt. It is equation number 2. This one is the equation number 1. Now Vx is equal to U cos theta, Vy is equal to U sin theta minus gt from equation 1 and 2. Since Vx and Vy component are mutually perpendicular to each other, their resultant velocity V is given by using the Pythagoras theorem, V is equal to root under Vx square plus Vy square. Is it clear? You know that one. V square is equal to Vx square plus Vy square, or V is equal to root under Vx square plus Vy square. Is it clear? Therefore V is equal to root under U cos theta whole square plus Vy is equal to U sin theta minus gt whole square. Here it is in the form of a minus b whole square. Therefore we solve it according to that one. U cos theta whole square is equal to U square cos square theta, and a minus b whole square is equal to a square plus b square minus 2ab. Therefore a square is equal to U square sin square theta, b square is equal to g square t square minus 2a U sin theta b gt. Is it clear? Now we write V is equal to root under U square cos square theta plus U square sin square theta plus g square t square minus 2U sin theta into gt by solving. Now you see this one in this equation, U is taken common, then cos square theta plus sin square theta is equal to 1. All of you know that. Therefore U is taken common and we write U square into cos square theta plus sin square theta, g square t square, U sin theta into gt. Sin cos square theta plus sin square theta is equal to 1. Therefore V is equal to root under U square into 1 is equal to U square plus g square t square minus 2U sin theta into gt. It is the expression for resultant velocity of the projectile at any instant of time. Now if we want to find the direction of the resultant velocity, therefore let resultant velocity V makes an angle beta with x-axis or Vx, then tan theta is equal to Vy by Vx. That is the slope. Always tan theta is equal to y by x. Slope is equal to tan theta is equal to y by x. In here tan beta is equal to Vy by Vx. Therefore tan beta is equal to Vy is equal to U sin theta minus gt by U cos theta. This one value we have from the above equation. Equation 1, Vx is equal to U cos theta, Vy is equal to U sin theta minus gt. Therefore tan beta is equal to U sin theta minus gt by U cos theta. Therefore tan beta is equal to U sin theta by U cos theta minus gt by U cos theta. Is it clear? We separate it. No problem any. U cancel out. Sin by cos is equal to tan. Therefore tan beta is equal to tan theta minus gt by U cos theta. Is it clear? Again, if the resultant velocity makes an angle beta with the x-axis or Vx, then tan beta is equal to Vy by Vx. We put the value of Vy and Vx in the above equation. Tan beta is equal to U sin theta minus gt by U cos theta. Therefore tan beta is equal to U sin theta by U cos theta minus gt by U cos theta. We can do it. Otherwise, if you write up to this one result, no any problem. Tan beta is equal to tan theta minus gt by U cos theta. This is the direction. Therefore beta is equal to tan inverse small bracket tan theta minus gt by U cos theta. We can also write. No any problem. Is it clear? Now for your knowledge, kinetic energy at the highest point. What is the kinetic energy at the highest point? Half mvx square. Vx is equal to how much? U cos theta. Therefore, half mu cos theta whole square is equal to half mu square cos square theta. Suppose anyone asks you what is the linear momentum of the projectile at the highest point. At the highest point, velocity is equal to Vx, component of velocity is equal to u cos theta. Therefore, we write as P is equal to mvx, that is P is equal to mu cos theta. These are the 2 points. It is helpful in understanding the projectile motion. So keep in your mind, but for your exam point of view, time of flight, height attained, horizontal range is required, so that projectile moves in a parabolic path, and obtain an expression for the velocity of the projectile at any instant of time. These are the 3 important points. Up to this one you have to learn, and for your knowledge you have to write that one. Keep in your mind while you solving the sum. Thank you. If you have any doubt, then you can consult with me. Is it? Then I will solve your problem. Is it clear? Thank you and have a good day.